Hi, welcome to Parametric House. In this Paracourse lesson, I want to show you how you can produce a series of metaballs by defining a point, which is going to be the base points for the lines. And you can see I can change the height here. The number of division is going to increase or decrease the number of metaballs we can produce. I'm also going to explain how you can define a section curve. And as you can see, I can change this curve to produce different results. And also what I can do is to rotate this by rotate plane. As you can see here, I can change it in different locations to make different results. And at the end of this tutorial, I want to show you how you can use a dispatch to create solids from it. So you can see that this is going to be the final results and you can use it in your project. So in this Paracourse lesson, we're going to learn this step by step to produce a series of parametric metaballs. Okay, let's get started from scratch. What I want to do here is to first define a series of points. Assume that we have 3 points here and produce a line from it. These lines are going to go in the z direction so we can define the points. Then I'm going to divide these lines into a series of points and then give this to the Metaball 2D component. We are also at the end going to talk about a curve we're going to produce here to make the final results. So I'm going to go here and go to the curve menu, use this line STL component. And the reason I'm using this is that we can just draw a series of lines with a starting point. So just right click here and extract and set multiple points. Assume that we have 3 points here. Okay. The direction by default is in the Z direction, as you can see here. So you don't need to change that. And you can see that it's producing a small line here in the Z direction. I'm also going to give one number slider to this. And the reason we're using just one length is that the plane we're going to use has to be has to intersect with these lines altogether, because if this line is like larger, it's not going to intersect with these parts and we will run into problems. Okay, now that we have the line STLs, we just have to go to the mesh triangulation and you can find the Metaball isocurve here. And as you can see here, it's going to produce a metaball from a series of points for the point charges, planes, and this one is really good because we want the point from the isocurve intersection. So what I wanted to do here is to divide these lines into a series of points, curve, division, and assume that we wanted to divide these curves, the lines, into a number of counts. We can say from 2 to 30, and this is going to be the number of division for all of the lines, and we can give that to the points inputs. And if I just simplify this so you can understand what I'm doing, you can see that we have 3 lines and each of these lines have 10 points, so we have group data. Okay, but in this tutorial what we need here is, for example, these 3 points has to be in one plane and we want to find the metaball for these 3 points, right? So this is going to be the first group and it's going to be like 3, right? So for example, for this 3 point, it has to be like 8 and n equals to 3. What we have to do is to flip the matrix for the points. I'm going to make it 10 groups of 3. Just search for flip matrix and give it to this input, and it's going to be like 10 groups of 3. So that is going to be the first input for the plane, the points. What I want to do is also give the plane, and because we have 10 groups of 3,